Hi there. It's Dr. Maxwell here, and this is some additional practice for exam 3. Um, and the first question here is a true-false question. The main data types are categorical and numerical, and that is true. Um, and then the two types of variables are discrete and what? Well, that would be continuous. Continuous. Okay. Now, in this problem, we have a frequency and relative frequency table, and you're just supposed to match it to the histogram. So if you understand how a histogram works, this is pretty straightforward. The first column corresponds to this first interval, and it should have a height of 0.21. So this one does, and this one does. So far we don't know. The second column should have height 0.28. Well, this one does and this one does, but we can now rule this one out. The third column should have height 0.18, and so now we can rule this out and then just check. Yes, these all match the following. So the answer is B. Okay, let's see. We are asked to make a stem and leaf plot. So the smallest number is 21, I believe. So I need 2 as one of my stems, and I need 3. And do I need anything bigger than 3? Yep, I need to go up to 4. So now I'm going to do the initial one. I'm just going to go down column by column. So I see 3, 8, 3, 6. This is the leaves or the second digits. Then I see 3, 6, 3, 8. Now I'm looking here. 2, 3, 2, 1. Now I'm looking here. 3, 3, 2, 6. So we're just writing the second digits as the leaves. This is the stem, and these are the leaves. So now we have 3, 7, 2, 6. And then 3, 6, 2, 7, 3, 5, 3, 3. There sure are a lot of those in the 30s. 3, 4, 2, 2. 4, 3, 2, 8. And then finally 2, 7, 3, 6. And they said there are 20 of these, and you should do a quick check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So the second step is to put the data in order. I'm going to have to try to squeeze that in here. So let's cut this off here. So I have 2, I have 3, and I have 4. That will stay the same. So I'm going to carefully put these in order. That means I will go 1, 2, 3, 6, 6, 7, 7, 8. That's done. Now I have to put the numbers in the 30s in order. So I see 3, 3, then 4. The next is 5, then 6, 6, 6, 6. Okay, and then there's a 7 and 2 eighths. Okay, so now we can answer the questions. I'm going to get rid of this one over here, so we don't need it anymore. And we will see, what do we need to do? We want to find the median and the mode or modes. So the median, well, we have what? N equals 20. So if you divide n by 2, that equals 10. So this means we need the 10th plus the 11th divided by 2. So let's find the 10th observation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're right here. That will be 33 plus 34 divided by 2. And so the median is 33.5. And in the mode, remember what the mode means: most often. Well, look at that. There's how many of those? There's 4 36s. So I bet that's the mode. And we are done. Okay. Calculate the mean of the following data set. All right, this is pretty easy. The sample mean, remember, is X with a bar on top. You just add these up. They don't have to be in order or anything. And then what are we going to divide by? Well, the number of observations. We have 1, 2, 3, 4, 5. So divide by 5. And when you do that, you should get, well, let me see. You'll get 58 divided by 5, which is 11.6. So that is the sample mean. Not bad. Okay, now we're going to have to find quartiles, the median, which is actually one of the quartiles, and the mode. Now, the tricky thing about this data set, it's not in order. So first I have to rewrite it. And one way to do it would be to make a stem and leaf plot. So maybe I'm going to do that. That's a quick way to order your data. So I need the first digit of 0 to accommodate these single digit numbers. Then I have a 1 and a 2. And let's see what happens. So I have 8, 15, 8, 20, 15, 15, 8, 20, 8, 8, 15, 20, 8, 20. Gosh, I'm losing my space. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm here. 20, 15. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I did a quick check by counting. I had too many 20s. If you look, that's how I was able to correct my stem and leaf plot. And now they're in order because this is a weird data set. So again, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n equals 15. Let's find Q1. That's the 25th percentile. So we take n and multiply it by 0.25 and see what you get. That is 15 point, nope, sorry, I did a calculator error, 15 times 0.25 is 3.75. And what does that mean? How to interpret it? Use the fourth observation, which is 8. So Q1 equals 8. Now let's find Q2. That's the median, which is the 50th percentile. So we take 15, multiply it by 0.5, and pretty sure that's 7.5, but let's make sure. Yep. What does that mean? Use the 8th observation. If it's not a whole number, you round up. So what is the 8th observation? 1, 2, 3, 4, 5, 6, 7, 8. 15. Now let's find the third quartile. That's the 75th percentile. So we take 15, multiply it by 0.75. What do you get? 11.25. And remember, we're not using rounding rules. We're using the rules for quartiles. If it's not a whole number, we always round up. Get the 12th observation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Q3 equals 20. Okay, and also this is the median right there. So the last thing we need to find is the mode, and I suppose that is the number 8 because it occurs 6 times, 15 occurs 5 times, and 20 occurs 4 times. Okay, this is just true or false. The second quartile, Q2, equals the median. This is true. Let's see what number 8 says. The IQR is the difference between any two consecutive quartiles. No, that's Q3 minus Q1. So that is false. Now, you will have to do something like this on exam 3. So make sure you understand how this goes. You don't have to put, these are our little XIs. These are my observations. I'm going to put them in order because usually that's what students do. 25, 26, 27, 30, 37. And I have 5, so n equals 5. First thing we need is the mean. So you add these all up and divide by 5. See what you get. I got 145 divided by 5. So that means the mean is 29. Now, in this column, we take each observation over here and subtract the mean. So, for example, in here, I'm going to do 25 minus 29. So what will that be? That's -4, right? So if you're doing this in your calculator, as soon as you do that, then go ahead and square it. And that's 16. Then 26 minus 29, that's -3. Go ahead and square it. That's 9. 27 minus 29, -2. Square it. 30 minus 29 is 1. 1 squared is 1. And 37 minus 29 is 8. Square it. And now we want to see what the totals are. This one should be 0. So check, make sure that it is. Yes, this is 0. So that's a good sign. If you don't get 0 here, then you've made a mistake. Now add up the numbers in the other column. Got 94. Now I have to understand how this formula works. Remember what we do. We take S is going to be the square root of the sum of the squared deviations, that's 94, divided by n minus 1, which is 4. So put that in your calculator. And you should get 4.85 if you round to 2 decimal places. Okay, so that's the average distance from the mean, the standard deviation. Okay, now we have a stem and leaf plot done for us, and we're just asked to calculate the median. So, how many scores are there? It doesn't tell us, so I'll have to count. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the median, you take n, divide it by 2, or alternatively, n times 0.5. This is the same thing. This will equal 11. Well, let me write that a little better. 22 divided by 2 is 11. So what does that mean? We want the 11th plus the 12th divided by 2. So find the 11th and 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like right there. 70 plus 71 divided by 2, which is simply 70.5. We're also asked for the mode or modes. Let's look and see. What do we have? Okay, 58 occurs twice, 74 occurs twice. So I would say the mode is 58 and 74. There are 2 modes in this case. All right, this is a box plot in a different orientation. Everything is the same. This is the minimum. This is Q1. The dark bar inside the box is the median, Q2. The top of the box is Q3. And this is the maximum. So the median is 1.6. Q1 is 1.2. Q3 is 1.8. Now, a couple of questions. What percentage of the lizards were slower than 1.6? Well, 1.6 is the median, so that means half of them, 50%. What percentage of lizards were faster than Q3? Well, this is the 75th percentile. That means 75% were slower, so 25% were faster. All right, let's see. We're given the mean. And we're given the standard deviation. What percentage of observations fall within 1 standard deviation from the mean? So this is how we do this. You have the mean here in the middle. That's our mean. Now, I'm going to go 1 standard deviation above the mean, and I'm going to go 1 standard deviation below the mean by calculating these numbers. Take the mean and add the standard deviation to it. Take the mean and subtract the standard deviation from it. And then we get this little window around the mean. So if I add the standard deviation to the mean, I get 48.6. If I subtract the standard deviation from the mean, I get 25.9. So I want to know how many of these observations are in this window. Well, I can't include 25 because 25 is somewhere over here, right? But I can include 32, and I can go all the way up to 42. So I have 1, 2, 3, 4, 5, 6 out of how many? How many are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 out of 10 times 100 to get a percentage is 60%. Okay, let's see what's next. Which of the following data types are continuous? The number of people who entered the building today. Nope. You can't have 2.5 people. It didn't ask for the average number, it asked for the actual number. Time is continuous. The number of computers sold. Nope. You can't sell half a computer. Well, you might be able to, but that's not what we're talking about. Weight is continuous. So what are these others? What would you call them? These are discrete. Okay. Now, this is a fairly simple problem as long as you know what to do. You want to take the frequency and divide by the total, and we're not given the total, so that's the first thing you need to do. Add the numbers all up, 3 plus 8, and you get 35. And so the relative frequency is calculated by dividing each of these numbers by 35. So let's do that calculation. So here I've rounded to 3 decimal places. There were no instructions. There will be on your exam. And let's just go over rounding rules real quick. 3 divided by 35. If you do this in your calculator, you get 0.08571 and other digits. So we want to round to 3 decimal places. So to make the decision of whether you increase it or not, you look at the next digit. If it's greater than or equal to 5, we round up, which is the case we had here. So that's why I did that. On the other hand, if you look at 2 divided by 35, you get 0.0571 dot, dot, dot. And in this case, we're rounding to the 3rd decimal. This is less than 5, so we don't round up. We leave it as is. Now, all that's left is we need the totals, and then we're going to answer these questions. So let's add these up and see what you get. Ideally, it should be 1, but remember, we rounded, so we have a little bit of a rounding error. If you're slightly above 1 or slightly below 1, that is not a problem. Now, we got to answer some questions down here. And we can do this using the table. So first, let's look at A. What proportion had heights less than 73 inches? Well, that would be all of these people. Now, you could add up your decimals or you could add up the frequencies. So I'm going to say this is 3 plus 8 plus 15 plus 7, 33 over 35. And see what that is. I get 0.94. Got to round to 2 decimal places. Okay, what percentage had heights greater than 69.9? Well, that would be these guys. These are taller than 69.9. Those numbers up. We get, for this one, 24 out of 35. This is 0.69. I'm just going to round to 2 decimal places. And the last question says, what proportion of the 35 adult males had heights between 70 and 71.4, right here. So that's 15 out of 35. And what do we get? 0.43. Okay, so let's take a break now. We've done problems 1 through 14.